The symbols of the units are not expressed in plural form. Example, 10 kilogram, not as 10 kgs. When temperature is expressed in Kelvin, the degree sign is omitted. Example, 283 Kelvin. Not degree sign should be include. Example, 100 degrees Celsius, not as 100 C. 108 degree Fahrenheit, not as 108 F Fahrenheit. Use of solids slash is the recommend for indicating a division of unit symbol of another unit symbol by another unit symbol. Not more than one solidus is used. Example, 1 ms minus 1 power minus 1 or m slash s, j slash k slash mol should be j k power by minus 1 mol power by minus 1. The number and unit should be spread by a space. Example, 15 kilograms minus power minus 1, not as 15 kilograms minus 1. Accepted symbols alone should be used. Example, ampere should not be written as AMP and second should be not written as SEC. The numerical values of physical quantities should be written in scientific form. Example, the density of mercury should be written as 1.36 into 10 power 4 kilogram power minus 3, not as 13600 kilogram minus 3. 1.6. Vernier caliper and screw gauge. In our daily life, we use meter scale for measuring lengths. They are calibrated in centimeter or millimeter. The smallest length which can be measured by meter scale is called least count. Usually, the least count of a scale is 1 millimeter. We can measure the length of object up to 1 millimeter accuracy with the scale. By using vernier caliper, we can have an accuracy of 0.01 millimeter, and with screw gauge we can have an accuracy of 0.01 millimeter. Description of vernier caliper. The vernier caliper consists of a thin long steel scale graduate in centimeter or millimeter called main scale. To the left end of the main scale, and upper and lower jaw are fixed perpendicular to the bar. These are named as fixed jaws. To the right of the fixed jaws, a cylinder with an upper and lower movable jaws is fixed. The cylinder can be moved or fixed to any position using a screw. The vernier scale is made on the cylinder and it moves along with the movable jaws and the cylinder. The lower jaws are used to measure the external dimensions. and the upper jaws are used to measure the internal dimensions dimensions of the objects. The thin bar attached to the right side of the vernier scale is used to measure the depth of hollow objects. This is the vernier caliper jaws diagram. These two are inside jaws. The scale is main scale. This is vernier caliper. This is vernier caliper. This ball is object. This is outside jaws. Usage of vernier caliper. The first step is using the vernier caliper is to find out its least count, range and zero error. A. Least count. Least count of the instrument LC equals value of one main scale division by total number of vernier scale division. The main scale division will be in centimeter, further divided into millimeter. The value of the smallest main scale division is 1 millimeter. In the vernier scale, there will be 10 divisions. LC equals 1 millimeter by 10 equals 0.01 millimeter equals 0.01 centimeter. Zero error. Unscrew the cylinder and move it to the left such that both the jaws touch each other. Check whether the zero marking of the main scale coincides with that of the zero of the vernier scale. If they coincide, then there is no zero error. If they do not coincide with each other, the instrument is said to process zero error. Zero error may be positive or negative. If the zero of a vernier is shifted to the right of the scale, it is called positive error. On the other hand, if the zero of the vernier is shifted to the left of the zero of the main scale, then the error is negative. Positive zero error. Figure 1.3. This is figure 1.3. Shows the positive zero error. From the figure you can see that zero of the vernier scale is shifted to the right of the zero of the scale. In this scale, the reading will be more than the actual reading. Hence, this error should be corrected. In order to correct this error, find out which vernier division is coinciding with any of the main scale divisions. Here, fifth vernier division is coinciding with a main scale division. So, positive zero error equals plus 5 into LC equals plus 5 into 0.01. Hence, the zero correction is minus 0.05 centimeter. This is the positive zero error. Problem 1. Calculate the correct reading. If the main scale reading is 8 cm, vernier coincidency is 4 and positive zero error is 0.05 centimeter. This is the question for this solution. Correct reading equals 8 centimeter plus 4 into 0.01 centimeter minus 0.05 centimeter equals 8 plus 0.04 centimeter 4 minus 0.05 equals 8 minus 0.01 equals 7.99 centimeter. This is the answer. Negative zero error. Now look the figure 1.4. You can see that 0 of the vernier scale is shifted to the left of the 0 of the main scale. So the obtained reading will be less than the scale actual reading. To correct this error, we should first find which vernier division is coinciding with any of the main scale divisions as found in the previous case. In this case, you can see that sixth line is coinciding. To find the negative error, we can count backward from 10. Here, the fourth line is coinciding. Therefore, negative zero error equals minus 4 into LC equals minus 4 into 0.01 equals 0.04 centimeter. Then 0 correction is positive. Hence 0 correction is plus 0.04 centimeter. This is the negative zero error scale. This is the positive zero error scale. Okay. Next, problem 2. The main scale reading is 8 centimeter and vernier coincidency is 4 and negative zero error is 0.02 centimeter. Then calculate the correct readings. Okay, question. Solution. The correct reading equals 8 centimeter plus 4 into 0.01 centimeter plus 0.02 centimeter equals, this is the answer, 8 plus 0.04 plus 0.02 equals 8.06 centimeter. We can use vernier caliper to find different dimensions of any familiar object. If the length, width and height of the object can be measured, volume can be calculated. For example, if we could measure the inner diameter of a breaker using appropriate jaws as well as its depth using the depth probe, we can calculate the inner volume. Thank you.